Welcome all physics tutorial class follower. My name is Waktola. In this video, we'll be discussing on grade 12 physics entrance exam practice part 6. This program is essential for students who will take grade 12 entrance exam, especially on recent Ethiopian new curriculum. To get all my video, please like, subscribe and share this program. Our title says that grade 12 physics entrance exam practice part 6. First, we see the question. Next, explaining each alternative one by one. Finally, we go to the conclusion. Question number 1. Choose the correct. Which one of the following describes Kepler's law of planetary motion? Choice A. Each planet moves in elliptical path with the sun at one focus. Choice B. The line that joins the sun to the orbit planet sweep out equal areas in equal times. Choice C. The square of the time it takes the planet to go around the sun is proportional to the cube of its average distance from the sun. Choice D. The orbit of each planet is circular passes. Before go to the solution, let we interpret this problem. When we come to the Kepler's second law of planetary motion, it states that the line that joins the sun to the orbiting planet sweep out equal areas in equal time intervals. In other words, as planet moves along its elliptical orbit, it covers equal area in equal time intervals. This law helps explaining how planet's speed change as it moves close to or far away from the sun during the orbit. From this idea, the correct answer is B. B says that the line that joins the sun to the orbiting planet sweep out equal area in equal times. Question number 2. Question number 2. Planetary motion uses the following principle except choice A. Kepler's law, choice B. Universal gravitational law, choice C. Conservation of angular momentum, choice D. Columbus law. When we interpret this problem, planetary motion follows several fundamental principles. Let us examine each option. The first one, Kepler's law. This law describes how planets move in elliptical orbit around the sun. They are essential for understanding planetary motion and were formulated by John Kepler in early 17th century. The second, universal gravitational. This law discovered by the Sir Isaac Newton states that every masses attach every other mass with the forces proportional to the product of their masses and inversely proportional to the square of the distance between them. It plays a crucial role explaining planetary motion. The second one or the third one about this law, conservation of angular momentum. This principle states that the total angular momentum of the system remains constant unless acted upon by the external torque. It is relevant in various physical contexts, including the planetary motion. From this one, when we come to Columbus law, this law describes the electrostatic force between charged particles. It is not directly related to planetary motion, but rather applies to the interaction between electrical charged objects. Therefore, the correct answer for this problem is D. D says that Columbus law. The next question, question number 3. Question number 3 says that which one of the following expression is correct about the relationship between periods and the mean distance of two planets around the sun? Choice A says that, according to the given this one, choice A, T1 over 2, the whole cube, which is equals to R1 over R2 square. Choice B, T2 over T1, the whole cube, which is equals to R1 over R2, the whole square. Choice C, T2 over T1, the whole square, which is equal to R1 over R2, the whole cube. Choice D, T1 over T2, which is equals to R1 over R2, the whole cube. Kepler's laws of planetary motion describes the orbits of planets around the sun Let us explore these laws and find the correct expression. Kepler's law, first law, or laws of orbit, say that according to the first one, the orbit of planet is an ellipse with the sun at one of the two focus. The Kepler's second law, or laws of area, a line segment joining planet and the sun sweep out equal areas during equal intervals time. The third, Kepler's law, laws of period, the square of the planet orbit period is proportional to the cube of length of the semi-major axis of its orbit. Let us compare these laws to give an expression. The correct answer from the above, the correct answer is D. D means, among the given this one, D say that R1 over R2 the whole square, which is equals to, T1 over T2 the whole square, which is equals to R1 over R2 the whole cube. The next question, question number 4 says that the law that states every particle attracts every other particle in the universe with a force directly proportional to the product of the masses and inversely proportional to the square of the distance between them is A. Choice A, Columbus law. Choice B, Newton's law of universal gravitation. Choice C, Faraday's law. Choice D, Kepler's law. Let me interpret this problem before go to the answer, the solution. Newton's law of universal gravitation, according to the law, this law, every particle attracts every other particle in the universe with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This fundamental law explains why objects fell into the ground, why planets orbit the sun, and why the moon revolves around the earth. It is cornerstones of classical physics, and we found formulated by Sir Isaac Newton in 1687. This universal gravitational equation takes this one, which is F is equals to G times m1 times m2 over r square, where F is represents the gravitational force between the bodies, m1 and m2 are the masses of the body, and r is represent distance between the center of the two bodies. G is a universal gravitational constant which has a value of approximately 6.67 times 10 to the power of minus n Newton meter square per kilogram square. This law beautifully explains the motions of celestial bodies and the force that keeps our feet firmly planted on the ground. From this one, the law that describes the gravitational interaction between particles is according to the given this alternative, the correct answer is B. B says that Newton's law of universal gravitation. The next question number 5. The gravitational force exerted by the sun to keep planets and other objects in their orbit acts as A. the centripetal forces, B. repulsive forces, C. outward forces, D. torque. When we come to the interpreting this idea, the gravitational force exerted by the sun to keep planets and other objects in their orbit acts as the centripetal forces. This force pulls the planet toward the sun, creating a circular motion around it. Additionally, the planet's inertia, or the tendency to maintain speed and keep moving, also contributes to their orbits. Together, gravity and the inertia work in harmony to maintain the planet's constant motion in their elliptical paths around the sun. So the correct answer for this question, A, is what? The centripetal force which is pushed to the center. The next one, question number 6. Question number 6 says that planet X and planet Y have the mass 9 times 10 to the power of 24 and 4 times 10 to the power of 25 kilograms respectively. If the gravitational force between the two planets is 6.767 times 10 to the power of 20 Newton, then the separation between the planet is A, choice A, 3 times 10 to the power of 9 meter, choice B, 4 times 10 to the power of 9 meter, choice C, 6 times 10 to the power of 9 meter, choice D, 2 times 10 to the power of 9 meter. Let us use Newton's law of universal gravitation to find separation between planet X and planet Y. The formula using F is equals to G times M1 times M2 over R square, where F is represents the gravitational force, G is gravitational constant, R is the distance between. So when we insert the given value into the equation, by rearranging this, the given gravitational force between the two planets is what? 6.6 times 10 to the power of 20, and rearranging and inserting this value into this equation, finally we'll get what? R is equals to 6 times 10 to the power of 9 meter. So the correct answer above this one is what? C. C says that 6 times 10 to the power of 9 meter. Number 7. The reason why planets do not fall into the sun from this strong gravitational force is due to A, high enough radial acceleration of the planets, choice B, counter repulsion forces, choice C, balanced forces of the repulsions and attraction forces, choice D, high enough tangential velocity of the planets. When we reason out why planets do not fall into the sun from its strong gravitational force is due to a high enough tangential velocity of the planets, our planet Earth, along with the other planet, orbits the sun because it has a significant sideways velocity. This velocity prevents it from falling directly into the sun. The gravitational pulls the sun keep and the planet in orbit, and their force forward motion balances the inward gravitational forces. Essentially, they are continuously missing the sun as they travel around it. This concept is consistent with Kepler's law of planetary motion. So the correct answer, according to the above, D, enough tangential velocity of the planet. The next one, choice in question number 8. Which one of the following is incorrect about properties of the states of matter? Choice A, liquid have relatively high density compared to the gases and solid. Choice B, liquid exhibit surface tensions that allows them to form droplets and hold together like film. Choice C, gases are fluid and can flow easily. Choice D, particles in solid are held together by strong intermolecular forces, resulting in rigid structures. The incorrect statement about this property of state of matter is what? Liquid have relatively high density compared to gases and solid. In reality, liquids have a moderate density, falling between the low density of gases and the high density of the solid. Liquids are what? Characterized by their ability to flow and take the shapes of their containers. While containing a definite volume, they also exhibit surface tensions, allowing them to form droplets and hold together like film. Gases, on the other hand, a highly fluid can flow easily, while particles in solid are indeed held together by strong intermolecular forces, resulting in a rigid structure. The correct answer from this one, A says that liquid have a relatively high density compared to gas and solid. The next question, number 9. Static fluid pressure depends on the shapes, choice A, shapes of the container, choice B, surface area of the containers, choice C, total mass, choice D, depth of the fluid. When we come to the idea of this problem, the static fluid pressure is primarily determined by the depth of the fluid. It is independent of the total mass, surface area of the containers, and the shapes of the container. This pressure arises from the weight of the fluid and can be expressed as pressure. P stands for what? Pressure is equals to rho times G times H, when P is standing for what? Static fluid, rho is what? Density fluid, G is what? Gravity, acceleration due to gravity, and H is what? The height of the depth of what? The liquid. In summer, the pressure in a static fluid depends only on its what? Density and the depth, regardless of the continuous shape or the total mass. So the correct answer, D, means depth of the fluid. The next question, which one of the following is incorrect about density? Choice A, it is characterized property of any pure substances. Choice B, it is used to determine whether an object sinks or floats in fluid. Choice C, it is mass per unit volume. Choice D, density of the copper depends on its masses. When we come to the idea of this problem, density is the characteristic property of any pure substance, and it defined as mass per unit volume. It is used to determine whether an object sinks or floats in liquid. The density of a substance remains constant regardless of the shape, size, or the amount of the substances. Therefore, the statement that the density of the copper depends on its mass is incorrect. From this choice, the correct choice is what? The correct answer is D. D means density of the copper depends on its masses. This is in general. Today we discuss on what some questions concerning about grade 12 physics entrance exam practice. If you have any question, write me your comment to me. To get the next video, please don't forget like, subscribe, and share this channel. Thank you for attention. Thank you.